Welcome everybody to our second project of this course, which would be a vulnerability scanner. Alright, so what we did by now is we created our port scanner, which managed to scan multiple targets as well as one target, and also discover which ports were open and closed, and we also managed to discover some of the softwares running on those open ports. Alright, right now we want to advance our game and create a vulnerability scanner which will be able to detect which of those softwares are potentially vulnerable to some type of the attack. So there are a few approaches that we can do in order to create this. I picked one which is going to be based on our port scanner, meaning that we are first going to import our port scanner, we're going to scan for the open ports, then we're going to create a list of vulnerable softwares in a TXT file, which then we're going to also import into our program, and then we're going to compare the softwares on the open ports with the softwares named in the list or in our TXT file, and if they do match, that means that we discovered a vulnerable software which can be exploited. Alright? Now you can actually download some of these vulnerable softwares list over the internet, or for the purposes of this tutorial you can simply just create a small list of a few softwares like I will in order to test our program. But before we do any of that, let us open up our PyCharm and create our new project. Alright, so I will open up my PyCharm by going here and typing PyCharm. Here it is, it loaded fully, and by default it will open up our previous project, which will be the port scanner project, but we do not want to continue coding inside of that project. We want to create a new one, and then we are going to copy paste the port scanner into that new project. Alright, so let's wait for it to reopen all of the files from the port scanner project. Okay, so here it is. Now, let's go onto the file right here, click on the new project. Under the create new project, in the location, we can create a name for our new project, which would be vulnerability, or let's just type vuln scanner. It doesn't really matter, you can call it anything you want, and then click on create. It will ask you whether you want to open the project inside of this window or whether you want to create a new window for it. We can simply just create this window and it will open up the new project that we just created. Alright, so here it is, it's creating all the dependencies needed. And right now what we're going to do, we're going to open up our terminal. We are going to navigate to our port scanner project using our terminal, and then we'll copy our port scanner to the vulnerability scanner. Right, so let's go to the PyCharm projects. If I type ls, here are both of these. Then we want to navigate to the port scanner, type ls once again, and we want to copy the port scanner.py into the vulnerability scanner directory. Alright, so cp port scanner.py to the root, PyCharm, and then vulnerability scanner. Press enter, and in just a few seconds we should see our port scanner right here. Okay, so here it is. Let's open it up. And here is our program. Now, as I mentioned previously, we're going to base our vulnerability scanner onto this port scanner right here, but we're not going to code it right in this program. We're simply just going to import our port scanner as I showed you in the previous video how you can do that, and we're going to perform some small modifications to this program right here. For example, we want to make this program a class, so we're going to delete some of the functions right here. We're going to modify this part of the program, and we're going to create this to be one giant class. Alright? But more about that in the next tutorial. For now on, we just simply copy this, we created our new project, and in the next video we're ready to start coding our vulnerability scanner. Alright? So, see you there and take care. Bye. Welcome back everybody. So for now we haven't really done anything yet, but we did import our port scanner, and now we're ready to start coding the main part of the program. So let's go to the vulnerability scanner right here. Right click on it, click on the new, and click on Python file. So all of this stuff we already learned, we know how to do it, and let's create a program which will be called vulscan.py. Now, first thing that we want to do is, of course, to import our port scanner, which makes sure that it is in the same directory. That is important. And that is actually going to be the only library that we are going to need, since these two libraries, which are going to be the socket library and the IPY library, are already imported inside of this port scanner program. Alright, now you might notice once again that this IPY is actually red underlined, which means that this library does not exist inside of this virtual environment, and we already talked about this before. You need to actually pip3 install it inside of this virtual environment, so let's do that right away using our terminal. Make sure that you're using terminal inside of the PyCharm and simply just type pip3 install IPY. It will install the library for you, and as soon as it is finished, you should no longer have this red underlined. Alright, so let's see. Here it is gone now, and now we have all of the libraries needed to complete our project. Alright, so let's go back to our main part of the program. We imported our port scanner, and now let's think about all of the things that we need in order to complete this project. So first of all, of course, we need the target that we are going to scan, so we want to prompt the user of this program for the target's IP address. So let's call it target's IP equals input, and we're going to actually ask the user for the input of this. So let's type it like this, and then we can add a star sign, enter target to scan for vulnerable open ports. Okay, so this will be the target's IP. Once again, we also want to make sure that this can be both IP address and the actual domain name, but we don't need to worry about that, as that part of the code is already located inside of our port scanner that we imported. So no need to code it once again. Let's just go to the next line, and also let's ask for the user for the number of ports that they want to scan. Now we didn't use it in our port scanner, so why not use it right here? Let's say they want to scan 100 ports and a different user wants to scan 200 ports. Let's add that as an available option as well. So port number will be equal to the input, and in the second line we prompt the user for the amount of ports you want to scan. And let's also notify them inside of the brackets that 500 will mean first 500 ports. Okay? So in case they get confused, they know what they need to specify. Alright, now another important thing that we need to do about this line is we need to make sure that this port number is an integer value. For example, if the user specifies number 100, it will be stored inside of this port number, but it will be stored as a string and not as an integer. Therefore, we need to wrap this entire part inside of an integer function, and this integer function simply just converts whatever is inside of the brackets into an integer value. Keep in mind that you will get an error in case the actual user of this program specifies a string. For example, they type the word tree. Well, that word will not get converted to an integer because that is not possible. Therefore, this will only work if the user specifies the actual number, which should be the case, as we are indeed asking for a number. Therefore, we want to convert it to integer so our program can continue executing. Alright, so now that we got these two things out of the way, there is a third and last thing that we need to ask the user before we actually start running the main part of the program, and that is going to be the actual file from which we're going to read vulnerable softwares. So for this program to run, we need a file. As I mentioned at the beginning of this section, we need a file that is going to store vulnerable software names that then we're going to compare with the softwares running on open ports. So we're going to call that, for example, vol_file, and it will be equal to the input let's add the double quotes. So to the input, and then we prompt to user enter path to the file with vulnerable softwares. Okay, so now that we finished everything, these are three things that we need in order to run this program. Let's print also the new line character. So right after this, we can have a little bit better view. And now we want to use the port scanner onto our program. Alright, so we're simply just going to call the function portscanner.scan onto the target's IP. Okay, now, if you think about this a little bit, you will notice that this will not actually work. Now, why this will not work? Well, there are a few problems with our port scanner, not with the port scanner itself, but with the way that we imported it and that we are going to use it inside of our vulnerability scanner. So first of all, we got a problem with this port number variable. We cannot really paste it into our scan function, as our scan function only takes one parameter. So that is the first problem, as we don't really have a way to actually tell the port scanner that we want to use this exact amount of ports. So that is the part that we also need to edit inside of our port scanner. Now, another thing that we want to do is we want to convert this entire actual port scanner into a class. And we also want to get rid of some of the functions that we don't need. And also we want to get rid of this part of the program. Since there is a lot to do with this port scanner, we're going to leave that for the next tutorial. So in the next tutorial, we're going to cover this port scanner and convert it to the best possible way for us to use it inside of our vulnerability scanner. And then we're going to continue from there. Alright, so for now, we simply just prompted the user for the needed things. And in the next video, we're going to cover the port scanner and how we can convert it the best way possible. See you there and take care. Bye. Hello everybody and welcome to this tutorial, and right now let's cover the port scanner conversion to a class. Alright, so anyone who's actually covered and learned Python before knows what classes are and knows why they are important, and in this case, in our case, we want to make sure that we convert it to class for the better usage inside of this vulnerability scanner project. Alright, so first thing that we're going to do is we're going to create the class at the top of this program. We're going to create it with the keyword class, and then we're going to call it, let's say, port scan. Open and close brackets and add two dots, and this is how we can create a class. Now, all of these functions that we have below, we want to make sure that they belong to our port scan class. So what we can do is we can tab each and every line. So let's do it one by one like this, and you will see that some of these actual keywords will start changing colors as they start belonging to our port scan class. Alright, so let's do it like this. All of it should be tabbed once, so let's go like this, and the scan port at the end. Okay, so here it is. Now, this part of the program, you might be asking what we're going to do with this. Well, in this case, we don't need it, so we can simply just delete that. All we need are our class with these functions right here. Let me just create space between each of these functions so we can see each and every one of them a little bit better. And now let's see what we need to do in order to get this to work. Well, first of all, we are missing a function that every class needs, and that is the init function. This init function will be coded at the top of the class, so right below the initiation of the class itself, we're going to type def __ init __. Alright, and you will notice that by default, if I open and close brackets, it will add this self argument as a parameter to this init function or init method right here. And this self argument basically means that it is belonging to this class, and what we're going to define inside of this init method is all of the stuff, well, all of the parameters that are going to define the object to our class. For example, we want to define the target parameter and the port number parameter. That is an actual attribute to our class which defines our object. Alright? So next to this self argument, we need to define those two attributes. So the first one we can call target, and the second one, which is the new one, will be called port _ number. Alright, so simple as that. And in order to define them inside of the init function, we simply just type self.target will be equal to target, and self.port number will be equal to port number. And this is just a Python way to actually define them, so nothing really important there. Let me just delete this empty space. And now that we have our init function, we need to add this self argument or self parameter to each and every function that belongs to this class. So we're simply just going to go right here and type self, We're also going to type self right here. Self right here. And self right here. And another very important thing that we should consider is that we don't need any of these other parameters outside of the self parameter. And why is that? Well, once you define those attributes that we need inside of this init method right here, we can access these variables throughout each and every function in our class. So we don't need to paste them as parameters. Let us just delete everything but the self parameter from each and every class. And right here as well. Make sure you do not delete it from the init methods. So let's leave it like this. So now that we fixed all of the methods, let's restructure our program a little bit. So I will start off with the scan port function. Alright, so what we're going to do with this scan port function, besides it doing the usual stuff that it did inside of our port scanner project, we're going to add the converted IP into the scan port function instead of the scan function. So we're going to delete it from the scan function first. Let's go right here. We also are not interested into printing anymore, since printing we're going to do in the main program, which is going to be the vulnerability scanner. So our scan function will be left with just these two lines of code, while the conversion of the IP address will be moved right here into the scan port function. So we're going to call the check IP function. And you will notice right away that some of the stuff inside of our class is actually red underlined. And by some of the stuff, I mean a lot of things, such as, for example, this check IP is underlined, these two variables are underlined, this get banner is underlined, the port is underlined. So all of this stuff are underlined, which means that they are not recognized by the PyCharm. Well, why is that? Let's start off first with the functions themselves as to why they are underlined. Once you create a class, you need to actually rename those functions when you call them inside of the class. You need to add the self argument before. So for example, if I type self.checkIP, you will notice that it will no longer be a red underlined, and this will get recognized by the PyCharm. This is just a way to call different methods from the class itself, so the class can recognize that this check IP belongs to its own methods, and therefore it knows which actual method to call. Same goes with this getBanner function right here, which we can simply just add self.getBanner, and it will stop being red underline. Let's see whether we have another function which is red underline. Here it is, scanPort. If I simply just type self.scanPort, we can see it works successfully. Now, but what are we going to do with these actual variables, which are red underlined? Well, first of all, we don't really need this IP address variable anymore, as we're actually getting the IP address from our main part of the program, which is going to be the target's IP variable right here. And then we're going to paste it into our class, which will then get stored inside of this self.target variable, which then we can use throughout our class. So let's change it everywhere we can. First of all, we're going to change it in the check IP method. So we're no longer checking the IP from the IP, we're checking the IPs from the self.target, and make sure that throughout of this class you also use the self argument when specifying the variable name. So we're trying the IP function from self.target, and in case it works, we're returning self.target. In case it doesn't work, we want to return the getHostByName from the self.target. Once again, keep in mind that this will store the IP address from our target machine. Same goes right here to the scan port. We don't really need this converted IP anymore. And why don't we need it? Well, we don't need it because, as you can see, the scan port function doesn't take the IP address as a parameter anymore. Therefore, this is red underlined, so we can simply delete it. But what with this port number? Well, we actually need to send this port as a parameter because we are inside of this for loop. Therefore, this port will change through each iteration, and we need to specify to this method right here, which iteration is it currently at. So we need to send the port as an argument. Therefore, we're going to go to the scan port, and next to the self, we're going to add port as a parameter, and you will see right here at these 3 spots, the red underline will go away, as this port now exists in this program. And the last part, which is red underlined, is this IP address right here. Once again, we don't really need this IP address anymore. We have self.target, and right here, since at the beginning of this try statement we converted the IP, we don't need to specify self.target right here. We can specify converted IP. Alright, since this will be the IP address, whether the target was specified as a domain or simply as an IP address. Alright? Another thing that we want to make sure is that we don't have unnecessary functions that can be put inside of a different functions. For example, this get banner can also be put inside of this scan port function. Therefore, we don't really need this method right here. So we can simply just delete the get banner, and we can put it right here. As you will see, this will get flagged as get banner doesn't exist anymore. Therefore, instead of trying to call this function, what we're going to do is we're going to write the get banner function code instead right here. So sock.receive. We want to receive 1024 bytes. And we're simply just using the sock object that we created right here. So no worries about that. We don't need to name it anything differently. We also want to decode the response. And the reason why we're decoding the response is so we don't really have to do it later on right here. So once we decode the response, we then want to strip it from any unnecessary characters, such as, for example, \n, and also we want to strip it from \r. And the reason why we are performing this stripping part is because, especially in this program right here in our vulnerability scanner, it is important to strip everything that we don't need from the response, as this banner variable will store the most important and crucial part to our vulnerability scanner. As inside of this program, we're going to compare this banner variable with the actual content from this vulnerability file in order if they match. So for example, if we have the same banner in a vulnerability file and the same banner gets retrieved into this variable, and imagine that we do not strip these actual characters from it, well, our program will not really find a match, as they will be different only by this character. So that's why we're stripping it, as the new line character is not important to us. Alright? So simple as that. The next thing we actually don't need is these print statements right here. We needed them inside of our port scanner project, but we don't need them anymore, as we are not really interested in printing which ports are closed and which ports are open, since this is not a port scanner. But however, there is another problem that will occur, and that is that this banner can only store one banner at a time. But we need to retrieve multiple banners if we find multiple ports open on the targets, and if we also manage to retrieve multiple banners from those open ports. So we will need to store multiple banners and not just one. So how can we fix that? Well, we can actually easily fix that. We can simply just add a list, which will be at the beginning of our class. Right here, we're going to call it banners, and in order to define a list, we specify these square brackets right here. By specifying open and close square brackets, we initiate that this banners list will be empty for now, and then every time we actually manage to retrieve the banner right here with this line, we can then right after it below append the actual banner to the banners list, just like this. And you will notice that this banners is red underlined. That means that we need to add the self.banners argument right here, and everything will work correctly. And in case we don't manage to retrieve the banner, we're simply just going to pass for now. Alright? And at the end, we can simply just close the connection with sock.close. So simple as that. Let me see if everything is correct for now. Everything seems to be good. Our get check IP function is good. Our scan is good. But don't worry. there is another thing that we actually have to do, which is going to be to create another list, which is going to be the open ports list. Now you might be asking, why are we actually doing this? And this is more easily showed than explained, but I will try to explain it anyway right now. And once we run the program, you will get it why we need this open ports list. For now on, let me just try to explain it. Well, once we actually created this class right here with these three methods, you notice that we also had to create this banners list right here in order to store multiple banners. Once we actually get to actually printing those banners and open ports into our vulnerability scanner, we want to make sure that each open port will match to each banner. And since we removed all of the print statements, we cannot really print open port one by one. We have to store all of the open ports somewhere and all of the banners somewhere, and then we have to print them, each element one by one. That's why we also need the open port list that we created right here, and after each time we manage to connect to a port, we will add that port to the open ports list. So self.openPorts and then .append, the same way we are adding the banners, we're also going to add open ports, and we're simply just going to specify right here port. Alright? Now, that is not the end of our problems. You noticed once we actually had port scanner projects that we had more open ports than more banners retrieved. For example, some of the ports that were open and that we tagged as open weren't sending us any banner, therefore we just didn't have banner for that open port. And that can present us a problem because if we have 10 open ports, for example, and we retrieve only 3 banners, then in one list, which will be the open ports list, we will have 10 elements or 10 ports, and in the banners list, we will have 3 elements. And therefore, once we want to print each element one by one, for example, the element 1 from the open ports should correspond to the element 1 from banners, and so on and so on. It will get confused in some of the open ports which don't have banners will get banners, and it will all get mixed up and it will not be correct. Therefore, we want to make sure that the open port list has the exact same amount of elements as the banners list has. So each element can respond to each element from the different list. How can we do that, since we are obviously going to have less banners than open ports? Well, we can fix that just by, instead of the pass statement right here under the except, we can also append to the banners list. So for each open port, we're going to append anyway. Even if it manages to retrieve the banner, we are going to append, and if it doesn't manage to retrieve the banner, we're also going to append. So self.banners.append, but in this case, we are simply just going to append empty space. We're not going to append any string or anything else. It will simply just be there, so an element can get added to the banners list. Alright? So we simply change this so we can have the same amount of elements in both banners and open ports. And with this, we successfully transformed our port scanner into an actual class that we can use inside of our vulnerability scanner project. And in the next video, we're going to see how we can call this class from our vulnerability scanner. Okay, so thank you for watching this tutorial, and I will see you in the next one. Bye. Let's see now how we can actually call our port scanner class into our vulnerability scanner program. Alright, so we have everything ready right here. We switched everything that we needed to. We also added some of the lists, some of the specific attributes to this class. We changed some of the functions as well as deleted the getBanner method from this class. And we also added the conversion of IP address into the scanPort method. Alright? So now that what we need to do is we need to see how we can create an object that will belong to this class and how we can use it inside of our vulnerability scanner program. Well, right away I can tell you that this will not work, because with this we're simply specifying the name of the file that we imported and then the function. But this function no longer exists as a separate function inside of the port scanner. That function is now the actual method to the port scan class. So in order to actually call that, we first of all need to create an object that will belong to that class. And we can simply call that object target. So simple as that. Target will be our object, and in order to initiate that object to belong to the port scan class, we first of all need to specify the port scanner, which is the file that we are using the class from, and then the name of the class itself. Now, you will notice that if I specify the open and close brackets, PyCharm will suggest right away that this port scan class takes two parameters. The first parameter will be the target's IP address and the number of ports that we want to scan for the vulnerable software. Now, why does it say these two parameters? Well, inside of our port scanner class, you will notice that we have two variables inside of our init method. And these two variables are exactly what we need to specify to our object. So we need to know the target's IP address as well as the number of ports. So let's specify that. We already prompted to the user for these two values, therefore we can simply just specify right here target's IP and then comma port number. Alright? And we successfully created the object to our port scan class. Right now, in order to initiate the scan itself, so we can scan for the open ports and retrieve the banners to those open ports, we need to initiate a method from this class. And how do we do that? We need to initiate a method onto our object from the port scanner class. So how can we do that? Well, first of all, we need to check which method we need to initiate, and ideally we want to initiate one method which will call all of the other methods as well. And in our case, that method would be the scan function, as the scan method calls the scan port method, and the scan port method calls the check IP method, as well as checks for the banners and adds them to the list. So we need to type right here target.scan, and simply with just these two lines, we perform the entire scan for open ports and softwares on our target's IP address. All we're left to do right now is compare those banners that we retrieved from the open ports with the banners that we will have in a separate file that we're going to create in just a second. And if we find a match, that means that we found a vulnerable software. Alright, so first of all, we need to perform something, and that will be the scanning of a target, and then we're going to add 2 or 3 banners to the actual txt file, which then we're going to use. Well, let me just show you. It is easier if I just show you. First of all, I will enlarge this, zoom this in, and I will navigate to our PyCharm projects as well as the port scanner project. And here, if I simply just python portscanner.py, and let's say we test this website, testphp.vulnweb.com, press here enter, it will scan for the open ports and we will retrieve some banners from it. Then we're going to copy these banners and add them into a txt file, which then we will use inside of this program. So let's say we want to copy first 2 banners. Alright, we're just going to wait for a few seconds for this scan to finish, and keep in mind we are using the port scanner tool that we created, so you can see it can be sometimes useful, especially when you try to gather more information about the target's machine. Alright, so here it is, it has finished. Now let's copy this. We don't need that IP address, we're going to copy this. Then right here under the Vault Scanner, we're going to click on New, but instead of new Python file, we simply just want to create new file. It will be called, let's say, vol_file, or no, let's not call it like the actual variable, volbanners.txt. Let's call it just like that, and then right here we're going to paste this as a first banner, and as a second banner we're going to paste, let's say, this. Copy selection and paste it right here. Alright, so here it is. We got 2 banners ready. And now let's see if we manage to find these 2 matches with our vulnerability scanner. Okay, so first of all, what we need to do in order to compare the banners with the banners from the file, we need to open that file first. So how can we do that? Well, in Python we do it with this statement. So with open, and then open and close brackets, and first parameter to this open function would be the file name, which is stored inside of this vol file variable. So with open vol_file, And the second parameter would be how you want to actually open it. In our case, we want to open that file for reading, so we want to read from it. You also have the write and append option, but in this case, we're going to open the file for reading, which we specify just by simply typing r. And then we specify as, and then the name of the file object as file. Let's call it like that. So with open vulnerability file for reading as file, then we need to perform the comparison of these banners. What we're going to do first is we're going to add a count variable, which will be equal to 0. And then we're going to take a look at all of the banners that we gathered during our scan. Alright, so how can we do that? We can access those banners by simply typing target.banners. How can we do that? Well, since we created this object right here, this object, besides these two variables, also has these two variables right here, or these two lists, should I say. So we can also access them as well if we want to, using our object. So target banners, and what we want to do with that is we want to iterate over it. So for banner in target.banners, we first of all want to navigate to the beginning of our whole banners.txt file, and we can do that using file.seek 0. And the reason why we need this line is because in case we remove this, it will only find the first result and it will not manage to find the second result, because it will take the first banner, then it will iterate over all of the banners inside of this list, and if it finds it, it will be stuck at the end of the actual file and it will not get back to read it from the beginning for the next banner. It will just read it from where it stopped. That's why after every banner we need to actually seek to the beginning of this file, which we do using file.seek 0. 0 means simply return to the beginning and read all over again. And now we need to iterate once again. So for line in file.readlines, and you will notice that we actually have two functions right here. One is readline and one is readlines. If you use readline, it will only read one characters one by one, so we don't really want that. We want to use readline, so it actually reads line by line. So let's just type it right here for line in file.readlines, and since this is a function, we need open and close brackets, and now we can compare the banners. If line.strip, we want to strip it from anything that might cause some problems in matching these two banners. And keep in mind that this line is simply just a line from the txt file. For example, it can be this, and then we need to compare that with the banners from this list right here. So if line.strip in banner that we are currently reading from this list. So if line.strip in banner, and then here we want to print, let's print it like this. So open single quote, 2 exclamation marks, and let's print in capital letters, for example, vulnerable banner. And then let's also add double quotes to our actual string, so we can add it between the banner plus the banner itself, plus, and then single quotes, double quote at the beginning, and then on port. And let's print it like this, plus the string. And here we want to actually print the port number corresponding to that specific banner. So how can we do that? Well, that is why we need this count variable, since this count variable will keep a track of each element that we pass by scanning each and every banner. So each and every banner will correspond to the exact same number of elements inside of this open ports list right here. So for example, if the count variable came to number 3, that means we are scanning third banner, and that third banner will be correspondent to the third element of the open ports list, which will be the actual port number to that specific banner. So in order to access that list, we need to type the target object dot open ports. We can access it the same way that we access the banners, so dot open ports. And here we need to specify which element are we looking for, and we specify that in the square brackets right here. So then we add right here count. So simple as that. For some reason we are getting these red lines in, for example, line.strip port scanner.port scan. And why is that? Well, let's just finish this so we don't forget the last line, which will be to actually increase the count variable by 1. And you need to keep in mind where are you actually increasing it, inside of which loop. Well, you want to increase it inside of this loop, but you don't want to increase it inside of this loop. So you want to increase it after you pass every banner. You increase the element by 1 because you proceed to the next banner in the list. Therefore, we want to increase it right here. So count plus equals 1. Okay, so everything seems to be working correctly. We just seem to have a bunch of errors right here, but let's try to run the program so we can see what type of errors are those. So we'll scan.py, and it says right here invalid syntax. Let's see where that is. Invalid syntax inside of the wall file. Okay, so we have a bracket extra, so let's delete this. Try it once again. Oh no, we actually do not have a bracket extra. We're not even fixing the correct part. It is inside of this wall file. Yeah, we have an extra square bracket right here, so let's delete that. And if I run it once again, we can notice that we no longer have any error. So this extra bracket right here created us the problem throughout the entire program. So now that we fixed it, this should work. Enter target to scan for vulnerable open ports. Let's type test.php.oneweb.com. We want to scan for first 100 ports because both of the vulnerable softwares are located inside of the first 100 ports. And we want to enter the path to the file with vulnerable softwares. Well, in our case, since the actual file is inside the same directory as our program, we don't need to specify the path. We can simply just specify the file name. But if this file was in another directory, you would need to specify the full path to that directory. In our case, wallbanners.txt. Press here enter, and now we wait for it to perform the scan first of the first 100 ports. Then it will go to this iteration right here with opening of the file and then comparing the banners, and if it manages to find the banner that matches in both of the banners list and the actual file that we open, then it will print that the vulnerable software has been found. Alright, so let's see right here. It might take a few seconds to finish. And here it is. We found two vulnerable banners as it prints right here. Vulnerable banner with this name right here on port 21 and vulnerable banner with this name on port 22. Alright, so good. We managed to find the vulnerable banners, and now we can simply just proceed to exploit the target with these two vulnerabilities. Alright, so that would be about it for this vulnerability scanner. As you can see, it is not really that big of a project. It is mostly based on our port scanner. We simply just compare the actual banners from the file and the scan itself, and then we print it out. Alright, so once again, this is something that you can download from the internet, or you can simply just create it by yourself, just by adding multiple vulnerable banners to this list and then creating your own list. And then you can use this program in order to scan the target. In the next video, we're going to perform the recap of this actual project. We're going to see once again how this program works, briefly explain it once again in case there is something that you missed or did not understand, and then we're going to proceed to our next project. Thank you for watching and see you in the next lecture. Bye! Welcome back. Let's perform a recap on our vulnerability scanner. Alright, so let's go step by step. So the first thing that we did is we imported our port scanner that we coded in the previous project. Now, in order for this port scanner to work, we performed some of the modifications to the code itself by adding the actual port scan class, which will have these multiple methods, and each one of them will perform a separate task. We also performed some little modifications to the actual parameters themselves and also deleted the getBanner function, and we put it inside of the scan port function. We also removed all of the print statements as we do not need them, and we added two different lists, which is the banners list and the open ports list, in order to be able to print the banners and open ports inside of our vulnerability scanner. After that, we then created these 3 variables which will store all of the needed information for our port scanner to run. We initiated an object right after it which will belong to the class port scan. We then initiated the scan itself by calling the scan method from the port scan class. After the scan has finished, we now know that after this line in our open ports list right here and in our banners list right here, we have all of the results ready. So then after the scan, we open the file which contains the vulnerable softwares on an open port. As soon as we open the file, we created the count variable, which is really important in order to keep the track of elements in the banners and open ports as well. After every banner that we scan, we increase the count variable by 1 and proceed to the next banner. And then we compare the line with the banner itself. And if there is any part that matches with the banner, we will print it as a vulnerable banner as well as specify which port the software is running on. Alright, so now that we recapped all of the things that we did, let's perform one final test to see whether it works. If I clear this, Python 3, and then volscan.py, let's perform the same test once again, volweb.com, first 100 ports, and volbanners.txt. Now you might be asking the reason why we are performing these recaps after every project. Well, it is in case you missed something or didn't understand something, so we just go over the code one more time in short term, and it will also help you to remember everything better and to fully understand the program once it is fully coded and once it is working as well. As we can see, we got the exact same result as in the previous video, and we managed to find both of the vulnerable banners, which is good. Now if I try to, for example, scan my router's IP address, 100 volbanners.txt, it will scan my router and you will see it will not find any vulnerable softwares as there is not any open port on my router which is running one of these 2 softwares. Alright, so that would be about it for this project. I hope you enjoyed it, and in the next video we're going to see how we can still gain access to the target machine even if we don't find a vulnerable software running on an open port and we don't know how to exploit it. We're going to take a look at some of the different things that we can do in order to enter the target's machine, such as, for example, performing the SSH brute force and gaining the SSH access to the target. So we're going to see how we can do that in our next project, and after that many more projects to go. So thank you for watching this tutorial, and I will see you in the next lecture. Bye!